Welcome to tonight's Frosty Drew live experience here on YouTube. And this is the first night that I'm going to run the whole thing. We're going to shoot for an hour and see how it goes. The skies are actually allowing us to do a kind of a hybrid event. So we've got a telescope set up to do remote viewing. You see, that's what you see now. That's the star Betelgeuse. It has a gray scale camera in it, so we won't get any color data, but we can at least kind of see what's in the sky. And other than stars, it's fairly accurate for what you would see from a color palette standpoint, because nebulas don't have enough light for our eye to receive enough light to do color information. And we'll kind of go from there. So I'm Derek, and with me tonight is Mara, and she's going to help moderate the chat channel. And if you have questions as we're going through things, please type a message in that chat channel, and we'll come to the questions at regular intervals throughout the night. The stream is a little delayed from real time, so if we're getting past your question, it's probably just because the video stream is up to a minute behind what we're actively talking about on the group chat here between Mara and I. So let's see where things go from here. So unfortunately, my laptop can't actually do all the presentation stuff that we're going to have to do tonight. So my main desktop is here on my left. As I'm looking at that, and for most of the night, you're going to look at the side of my face. So hopefully that's okay with everybody. And we'll go from here. All right. So as I said, the first thing we're looking at now is the star Betelgeuse. This is the top left shoulder in the constellation Orion, and it is one of the brighter stars in the night sky. It's kind of a fun starting point for nighttime astronomy because you can use it to line up your telescope, the finder scope, and all that kind of stuff. So let's slide this out of the way and zoom out. So you can see we're here on Betelgeuse. And the first thing we're going to do, we're going to go around the sky here in the Orion constellation and see what we can find. All right, so the first nebula that we're going to look at is M78. This is a reflection nebula that's about halfway between the star Betelgeuse and the Orion Nebula, which is also commonly called the Sword of Orion, that's just below the three belt stars. This is just above the three belt stars, kind of off to the left. So let's see if we can take a picture and see what we see. Where'd that button go? See, losing things already. Here we go. It takes about 10 seconds to get the image, and then it should show up. Then we'll talk about what we can see here once that loads. All right, so what we are seeing here is you can kind of see this dim nebula here around these two stars, and then a dark region below those two stars. So this is a fairly dim nebula, and it is not evident unless you really know that it's there to look for it. And it's kind of a good measuring stick for what we're going to see later tonight. So this nebula is kind of a component of a reflection nebula as well as an emission nebula. And reflection nebula and an emission nebula. And it was discovered by Charles Messier, who was a gentleman who put together a catalog of objects with a few of his colleagues back in the 1700s. And we use that list now in amateur astronomy because it is a list of fairly bright objects that we can see with our telescopes that we can buy that are mass produced. All right, so that's not a lot to look at. So let's go look at something that might be a little bit more interesting. We're going to go down to the Flame Nebula, which is just next to the star Alnitak, which is the left star in the belt stars in Orion. All right, so once again, we'll take a picture and we'll see how things go. Oh, I need to actually move the telescope. This happens more often than it should. So this is the first time we've done this like live telescope thing since last year. We've been clouded out so much that we've been doing a lot of pre-compiled images, and that one is a lot less error prone. So let's try that again. It was a good test run. Let's see. Okay.
There we go.
Excellent. We managed to hit it. All right. So one of the things you're going to notice here is obviously this bright star, which is Alnitak, and that is very close to this nebula here, which is it's two nebulas stacked on top of each other. You've got a dark nebula that's in between us and the background nebula, which is providing the light source. And that dark nebula is not illuminated on the surface that faces us. So its opposing surface that we can't see is probably illuminated. But what we see instead is effectively a shadow. And it kind of looks like a fire. And this is, upside down for the flame effect. So I'll flip it over. And you can kind of see that it's got that flame coming up through the base here into this illuminated nebula. Another common, or one of the, I've heard that some astronomers refer to this as a Christmas tree nebula because this kind of shape seems more like a Christmas tree. And really that comes down to the size of your telescope and how dark your skies are for how much of that nebula that you are seeing when you look at this with a telescope. And you can see this one with a telescope, and it is a little bit more apparent than M78. I'm trying to keep, I actually, throughout tonight, I'm going to take the exact same picture for all of the objects, just so that we don't get a misrepresentation for how bright different objects are. And this one is this one's an emission nebula that's, behind that dark nebula. And an emission nebula is the light is generated by ionization of the gas. And then the change in that ionization state for the gas molecules emits photons on specific wavelengths. In this case, it's most likely hydrogen gas, and that would be more in the red wavelength. Whereas some of the other gases, they emit oxygen. Oxygen emits in the greenish bluish domain, and then sodium is very close to hydrogen. So it's commonly two reds and a greenish blue, and then one of them is mapped to a different color to form what's sometimes called like the Hubble palette in narrowband astrophotography, which is a different style of astrophotography from RGB, which is just red, green, blue. All right. So from there, I think we're going to go down to M42, which is the Orion Nebula itself. This one's much, much bigger and brighter. I'll move this out of the way, and you can kind of get a feel for. So this yellow square is the size of the sky that we're looking at. That's the image sensor for the camera. And then this big green square that we fit inside of is actually the Orion Nebula. And we're going to go take a picture of kind of the core of that. Let's see here. See how things land up. All right. There we go. So we've got a little off center here, but we can fix that and try again. But this is the main center of the Orion Nebula, and then these are dust lanes or dark gases that are in front of the Orion Nebula that are blocking light. And sorry, I keep scrolling. I don't mean to. I mean to make this bigger. All right. And then this area back here is all illuminated by the stars that are forming out of this region of the sky. And the Orion Nebula is a star formation region. It's actually one of the largest ones. It's the largest one that's close to us and close enough to see naked eye. And we see this as kind of a blurry spot in the constellation of Orion, and it's sometimes called the Sword of Orion. Let's see. Any questions yet, Mara? Let's say we've gone through 4 or 5 objects. Let's see where we. Okay. All right. So I think from there, move this out of the way. So that's the overall constellation Orion. If you've been to the observatory, you're probably pretty familiar with that one. We show that constellation throughout the winter. M42, the Orion Nebula, being one of the more popular objects that we look at. And then we also do sometimes show the Flame Nebula. There's another nebula that's right next to the Flame Nebula. It's called the Horsehead Nebula. Unfortunately, that one is extremely dim and takes quite a bit of exposure time to be able to resolve that one. We can't do that one with our eye, at least with the telescopes that we have at the observatory. And there's a lot of good stuff in the Orion constellation, and it's actually used kind of as a navigation beacon for finding things in the winter sky. There's a halo of stars around Orion, and I'm not going to try to do it here, but if you're ever out at the observatory, ask about that ring of stars around Orion, and then the different directions you can get to from using Orion as kind of a pointer to get to things. So from here, I think we're going to try to go over to constellation Leo, which is kind of a spring constellation that's just coming up here. And we're going to, let's go sync the telescope over here to Regulus. And then we'll look at a few galaxies. Orion is on the Milky Way. It's kind of opposite the direction of the galactic core. So the Milky Way is not as prominent when looking through Orion. But that's why Orion has a lot more nebulosity and star forming regions and that type of that type of deep sky objects and its region. Whereas Leo's looking kind of out of the galaxy, and it's looking just ahead of a region of the sky that we call the Virgo supercluster. And that Virgo supercluster is really centered in Virgo, but it is, it extends into Leo, it extends into the constellations behind Virgo, above and below. And we're going to, as Leo starts to come up, that starts to signal something that we call galaxy season, because there are just piles and piles and piles of galaxies in that direction of the sky. And some are 30 million light years away, some are 100 million light years away, but they're fairly close by galactic standards, or sorry, by universe standards. By galactic standards, they're quite far away. Our galaxy in particular, is only about 60,000 light years across. So for something that's 30 million light years away, that is a pretty big difference, order of magnitude wise. Our closest neighbor is M31, as far as a full-size galaxy, and that's the Andromeda galaxy, and that's about 3 million light years away. Just to give you an idea of how close some things are, and then how far away kind of our neighborhood extends, because we are actually part of the Virgo supercluster as well, here in the Milky Way. And the universe extends to, I don't know, what's the number now? 15 billion light years? I don't know. That's not a number I keep up with. So one thing I wanted to point out on this image before we get away from it is down here in the bottom left, you see this streak, and that's actually probably part of a satellite going through our image as we were taking that picture. So, all right. Give me a minute while we line up the telescope on Regulus as a calibration point, and then we'll get over to our first galaxy. Yeah. All right. So if anybody was watching, the little white box that popped up is where the telescope was actually pointing, and the previous position was where it thought it was pointing. So now there's a digital model that the computer keeps for the telescope. So now that is synchronized, we can more accurately point the telescope in this region of the sky. So the first spot we're going to go is a grouping of galaxies. It's 4 of them, kind of all together, and it's a good rendition of what is available, or what is the variety of galaxies. In this image, we've got lenticular galaxies, which are also elliptical galaxies. We've got spiral galaxies. We've got disrupted galaxies. And then we have kind of some interaction going on. We'll see what shows up in our short picture here, and we might end up taking a longer picture or just using something that I took earlier in the week. We'll see how this goes. Galaxies are not nearly as bright as those nebula that we were looking at. When we look at these in the telescope at Frosty Drew, they're usually just brighter than the background space darkness. And a lot of times I describe what to look for as if you pulled a cotton ball apart and you laid it out on a black sheet of paper, and that's kind of what you're looking for, is just wisps of something that aren't black space. But anyway, let's see what we get here. So this is, if anybody's keeping track or wants to keep track, this is NGC 3189 is the center. This is a kind of edge-on spiral, barred spiral. And it has a few things around it. We're gonna have to take a longer picture. So let me turn that up, and then we'll get back to this. Or yeah, we'll just do that. That'll be fine. It's more fun. Let's go 30 seconds. We'll also turn up the gain. A little noise can't hurt anything. So what we're doing here is kind of, we're showing a live sky through using pictures of the sky, because taking this and trying to do it as a pure video, it just wouldn't work. The objects are too dim to be picked up by any reasonable video camera. I'm sure there's one out there that exists, and we just don't have it. So. But if anybody wanted to see, that's the current photo at 4 seconds. And if you look, you can kind of start to see it. There's a smudge here. There's a smudge here underneath this star. If you compare those two, they don't look like the same type of object. This one looks less focused. There's the beginnings of a smudge over here and the beginnings of a smudge here. And that's kind of when you're looking at galaxies visually, what you're looking for, and it's kind of a learned skill to be able to see these against the darkness of space. And we use a technique called averted vision a lot of times to be able to at least initially detect the difference. Because the center of your eye is actually pretty terrible at low light conditions. And did that get any better? I don't know. Doesn't look any better. All right, we'll go to one that I took earlier in the week just because I want to be able to show you guys some of this stuff. All right. See if this works. Oh my gosh. Okay. So this one is about an hour of capture time, and then a very rough. What happens after you take the data is it's not really. It doesn't look really a whole lot better than that, but the noise is lower than the signal to the point where you can start to separate them and establish what the distinguishing characteristics of the object that you captured are. So, all right, we slide this over here, and you can kind of see now you've got this kind of almost edge-on spiral galaxy. This dark lane across the middle is the dust lanes in the spiral galaxy, and then you've got this like kind of weirdly expressed S-shaped galaxy. The probable reason for that is it has interacted with this larger galaxy at some point in the past, and that's what's causing this distorted shape. And then you can also, if you look at this one, the dust lane doesn't quite look like it should because it's tilted compared to kind of the center line of the galaxy. And then down here, you've got another one that kind of looks like a donut with a galactic core. It actually looks a lot like if you've looked at Saturn through a telescope, it kind of looks like that. You've got, dark spaces between the planet and the rings, and then you have the rings that are, pretty easy to distinguish from the planet itself. And that's another disrupted barred spiral galaxy. Based on this picture, it might have interacted with one of these in the past. I don't know. All of these are at about 30 to 40 million light years from us. This is that elliptical galaxy that I was talking about. And really an elliptical galaxy is an older galaxy that has, very little structure. It's more just spherical or oblong, and it's kind of got a central axis, and that's about it with a halo of stars around it. It's been through so many interactions that it no longer has kind of a disk shape or what we would associate with kind of a younger galaxy, like a spiral galaxy. And then just to point it out, in this image, there's another galaxy here, much further away and it's smaller here, but that's just because of distance. You've got another one, a little one over here. Let's see. I think I can zoom in. Yeah, you can see that, that smudge is not as crisp as the neighboring stars. So actually, I think, there's another, there's something going on up here because there's a line next to this star. Maybe that's an artifact in the processing. I don't know. But that's, kind of a region of Leo, or Leo near the head that, has four pretty interesting galaxies in it that are, you can see this one naked eye, and sorry, not naked eye. You can see the primary one here in the middle with a telescope, and then these, if you had very very dark skies, you might be able to see them. And then, if anybody is curious, I'll zoom out on this so you can see where in Leo that is. So it's kind of going up the neck about halfway above that shoulder star and the first bend in the neck. So kind of interesting. All right, let's see. Do we have any questions?
Ooh. What planets will we get to see tonight?
All right. So planets, right now, the way the solar system is kind of lined up, the only planet we can see at this time visually is Mars. And it's very early in the night, in the evening. If you go outside and look towards the sunset, you'll see it near, actually, I think it's still technically up. Let's see. Yeah. So it's right near the Pleiades. We'll go over here and just answer that question real quick. So you've got the Pleiades here, which are the seven sisters. And then just to the left of it is Mars. And unfortunately, from where I am located, I have a lot of trees in that direction. So I won't be able to show you Mars tonight. But over the next maybe month, it's going to start setting earlier and earlier. And if you want to see Mars this year, before we lose Mars for, I don't know, a year or two because of the way the timing between Earth's orbit and Mars orbit, a month and a half is probably the limit before we'll be unable to look at that one, even out of the observatory where we have a pretty low western horizon at Frosty Drew. All right, let's see. Okay, answered that question. Excellent. All right, let's go back over here to Leo. So another spot in Leo that has a galaxy. All right, I know the number. NGC 2903. It's off the head of Leo here. There is another galaxy that's by itself, and this one is not disrupted like the four that we just saw. So we'll go over there and see what this looks like on a quick image. And if not, we'll look at a previously captured image. All right, let's see. Let's find that button. All right, so this is going to take a little longer. I'm taking a longer picture than we were for the nebulas. Went from 4 seconds to 30 seconds. So we'll see what happens. Oh, let me slide that in so we can see that when it does land. Go back. Well, come back. Oh well. Hopefully it'll pop over. All right, downloading the image, and It's a lot of patience in astronomy. All right. Nope. Where did that go? All right. We'll turn this on. Turn it back up. There we go. All right. So actually, this one does show up pretty well. We might be able to stretch the histogram a little more. Yeah, we're not gonna worry about it. So you can see here in this this area, there's the galactic core, and then you've got kind of a more defined galactic structure along this axis, and then it starts to kind of rotate around as if the galaxy was spinning counterclockwise. And as far as how that's actually structured, the telescope does flip the image because it uses mirrors to capture the light. So really everything here is flipped over from what it would be in the sky. So that would be clockwise in the sky. But you can kind of get an idea for what this galaxy might look like. And then just to give more of an idea, so we're not using so much imagination, let's do this. Yeah. So that is taking a stack of those images and processing it. You can see that this is a classic example of a barred spiral galaxy, with this center part being the bar, and then you've got the dust lanes that spiral around the core and kind of connect in through that bar. All right, so let's see where we can go from here. All right, and let's go find one more in Leo. There's another spot in Leo that has a really nice grouping, and it's called the Leo triplet. And that region of the sky is a pretty easy one to find for newcomers to astronomy, because you take the two stars that make up the back of Leo, this triangle, the right two, or the eastern two, the western two, and you draw a line between them, and then there's this star down here. And on the computer here, it doesn't look like it's jumping out as much, but visually, this star jumps out quite a bit more than what this computer is showing us. And right about halfway between these two stars is the Leo triplet. And you can see this with a pair of binoculars, and it's really quite visually pleasing. So we're gonna line up for this one and see what we get. And then we'll go look at the third component of it, because this telescope, the field of view is too small to see all three of them together. All right. Let's see. All right. Taking a picture. And then when I was kind of figuring out what we were going to look at tonight, I was kind of testing a few objects in the sky over the earlier nights this week that were clear, and I ran into kind of a neat accident. I ended up taking a sequence of pictures of an asteroid, and we'll look at those after a little bit here. And you can kind of see the asteroid moving across the field of view, which is kind of neat. All right. Well, um, all right. Well, I'll show this one, and then we're going to take another one. But you can see. Let's see. Let's do a quick. While I'm talking, I'll let this thing do its thing. So what we can see here, you can see a fuzzy spot here and a fuzzy spot here. And then if you notice, these stars are not round. So I took the picture too soon. The telescope hadn't settled yet. And this is what's called a star trail. And in astrophotography, it kind of makes, it's an indication that your image is, kind of not going to work, because this dim light from the galaxies is also being spread out, which is kind of why they don't look like anything. But something fun to talk about if you ever get into this type of observing or are interested in astrophotography at all. It gets interesting. All right, we'll line that back up, give it a good 10 count, and we'll try another picture. All right, let's see. And at the end of our session, I think we'll make an attempt at taking a picture of the Apophis asteroid that Scott had in his email. How well that's going to work, I don't know, but we'll give it a whirl. It's borderline in the trees from where I am currently. Aha, much better. Okay, so we'll slide this over. So now the stars are much rounder, which is good. And you can see this galaxy over here is kind of in this orientation, and it has a nice oval shape. And this one over here is maybe not as defined as an oval. And in the spirit of not relying completely on everybody's imagination, I'll pull up a stock image of that one as well. So this is just the M66 and M65 components of the Leo triplet. And these were taken earlier in the week. So this is a single image. It hasn't been processed. Yeah, that's a single image, right? Yes. Okay. So, yeah. So this is M65 on this side, and it has a very nice spiral structure. It's a little bit edge on, so we kind of have to, you're looking at the dust lane here just below the galactic core. And then over here, you've got a disrupted spiral galaxy, and it has what looks like maybe three spirals, and it just doesn't have a really good structure anymore. But it has some very nice dust lanes here that are probably fairly active star forming regions. Something interesting that happens when a galaxy gets disrupted is it stirs up all the gas that's in the galaxy, and it starts forming stars much more quickly than it was before the disruption. That's one outcome. Some other outcomes are less interesting. And these two are, like I said, they're visible in binoculars or in an 8-inch Dobsonian that we use in the yard of the observatory quite often. These are very apparent, and you don't have to use a lot of tricks to see these because they are quite bright compared to some of the other things that we try to look at through the telescopes. All right. So the last the last object I want to show is kind of is this one? Yeah. So is the other component in the Leo triplet. So we'll go take a quick image of it just so you can see kind of how that lines up. go here. Telescope. There we go. All right. So this is the galaxy that I was imaging earlier in the week when I accidentally took several sequence photos of an asteroid. And after we talk about this galaxy, we will look at that and talk about asteroids for a little bit. And then we'll try and do the Apophis image capture, which is going to be a trick because I got to use 2 different programs to go find it. It's moving quite a bit since it's so close. All right. We should be getting a picture soon here. All right. Nope. Try again. So this is another star trail symptom. So the telescope was still moving, but it settled, which is why they end in a bright dot. Thanks, Ken. So this galaxy is also called the Hamburger Galaxy because it has a really interesting gas halo around it. And when you process this galaxy away from the background of space, it kind of looks like a hamburger because the gas looks like a bun on top and below. And then that dust lane that we can start to see there in the middle looks like the hamburger. And you know, in this 30-second image, you can start to see this dark lane across the middle, and then you can kind of see the background below that, or behind that dust lane is the galactic core. And as with the other ones, in the interest of less imagination and more visualization, we'll take a quick peek at, this one. So this is one that I took earlier in the week. And you can kind of start to see how that gas halo, which, you know, encompasses the whole galaxy, and it actually goes off this way a little bit, really, you know, gives it kind of that hamburger-esque look. And that dust lane through the middle is quite nice because this is almost perfectly edge on. So it's back illuminated by that galactic core. So there's plenty of light behind it, and it really gives you a good idea for how dense that gas is there that's causing that dark line. Okay, so let's see if I can find the right window for looking at the, here we go. All right, so this is a sequence of about 30 images over the course of an hour. Each of them are 2 minutes. And we'll see a very small dot moving from right to left about, I don't know, 3/8 of an inch, you know, because that's a good scale on a computer monitor. But I'll point it out after I get this animation running. So if you look right here where the cursor is going this way, you'll see a little dot moving to the left. And at the end of the animation, a satellite goes through the image. That's what that bright line through the bottom is. But this, I didn't know what this was when I first saw it in the images. And I noticed it because when I was processing the images, I had a star that was moving, which stars don't move. So it wasn't a star, but I didn't know what it was. Looked in some planetarium software, couldn't figure it out, and ended up, you know, posting online. And a couple of people suggested that it is, and the asteroid, What did I do with it? I had the note written down. I thought I would remember, but I'm terrible with names. So here we go. Where did I put that? It's like starts with a 9 for its designation, and it's part of the asteroid belt, and it has a fairly circular orbit. So it's not like Apophis, which has garnered some stress over the years when people ran the numbers and it was getting really close to Earth in the case of Apophis, but not in any case. This one is not going to get close to us. So, all right, give me a second while I look this up, because I'd like to provide that with you guys, that information, or at least what we think it is, just for fun. All right, so there we go. So 9262, and then it's a Russian name, so I'm going to butcher this pronunciation, but Bordovitsia. But if you search in the Minor Planets database for 9262, it'll come up with that asteroid. And it's been known for quite a few years. I think it was discovered in the 1920s. So it's not even a really small one. A lot of the smaller ones have been discovered in the last few years, and we now know of hundreds of thousands of asteroids in the solar system. Everything from the size of a Volkswagen to the size of New York City or Texas. So I don't know. It's kind of fun. All right. So we'll check for questions, and then we'll see if we can take a picture of Apophis. Maybe. We'll see how this goes. So what I have to do for this is I have to load up a program called Stellarium, which has a database of asteroids. And Apophis, being kind of a major asteroid, is in that database by default. So I have to go find that, look up where it is in the sky, and then go over to the program that I control the telescope with and kind of convey the information. So if I'm quiet for a little while, that's why, and I apologize.
In the chat, we got Kenneth saying that it's pretty amazing that you call yourself an amateur astronomer, and it's just a hobby.
Yeah, just a hobby. 10 years in, still a hobby. All right, so we did a sync. And I've never done this with this program, so this is kind of a learning curve for me. I tried to do it the other night and failed, so we'll try it live. It always works live. All right, so I'm taking our first picture, and we'll see. This one's moving fast enough that I think it'll streak in a 30-second image, as compared to the background stars, unlike the one I showed you near the Leo triplet, which was moving much slower. Over the course of an hour, it barely moved, 3/8 of an inch across my picture at the scale I was showing it on the computer screen, which was like maybe 100 pixels total. All right, so 2 problems. We're in the trees. I was afraid we'd still be in the trees. So I'll show you the picture. I don't see anything that's obvious in here, but the dark and gray pattern across there tells me we're looking through a tree in my yard, which is unfortunate. I'll still try to get an image, and we can post it to the Science Center at Frosty Drew. So if anybody comes by, they can check it out. I think Scott's also trying to take a picture of this from Frosty Drew, but we'll see. That's the fun part of astronomy, is sometimes the weather cooperates, sometimes it doesn't, and then you still got to find the object once you got good weather. So it's
I'm not surprised if Scott doesn't. If Scott is trying to get this as well.
Yeah. So that, you know what? Let's switch sides of the sky and see if we can go over here. All right, so there's one object over here. Where's this thing? It's off of. We're not. That's definitely not high enough up out of the trees yet. In the Big Dipper, there's a nebula. It's called the Owl Nebula, and that one's a lot of fun to look at. I'm gonna try to show that to you guys in the telescope. I'll show you where it is, and then I'll show you a picture that I took earlier in the. Wow, I got lost. Here we go. Where are we going? Ursa Major. What's that? Here we go. Okay. So if you're familiar with the Big Dipper, or the actual constellation is Ursa Major, what we consider the Big Dipper is just a small component of Ursa Major. But you've got the bowl of the Dipper, and then the bottom 2 stars in that bowl, closer, to the end of the bowl, and just below that line is where the telescope, or where the cursor is pointed. The telescope's still pointed over at where we thought Apophis was, and that's where the Owl Nebula is. I know this is in the trees because I have terrible trees to the north And I'll show you a quick picture of the Owl Nebula. And this one's a planetary nebula, which is different than the other nebulas we were looking at earlier tonight in Orion. All of the nebulas in Orion were either reflection nebulas, which are, they've been illuminated by the light of stars, and we're just seeing, like what we would see, if light bounces off a wall. It reflects off of that nebula, or it reflects off of the wall. Or we were looking at an emission nebula where the gas is ionized by, starbirth, and we are seeing the actual chemical or physics of the ionization of the gas producing light. All right. Let's see. Where did I put that? All right. All right, so this is the Owl Nebula. Oops. Huh. Anyway, we'll pull that back up later. And it's really just the head of the owl. And when you look at this one in a telescope, the nebula really kind of, it jumps off of the darkness of space, and then the two eyes aren't jumping out as much, and it really looks like the head of an owl, like looking out of a tree at you, because of the way that some of the owls have those like different feathers around their eyes. So that one's kind of fun to look at, and because of where it is in the Big Dipper, it's actually visible year-round for us here in New England. The Big Dipper is a constellation that is considered circumpolar, meaning that it goes around Polaris, because that's the star in the sky that most closely approximates the North Pole of Earth, where it's pointing. And as Earth rotates, the stars rotate around that spot. And that's what we call circumpolar, anything that stays above the horizon all year. The Big Dipper is one of those constellations, and actually it's crazy when it's sitting low in the horizon and basically due north. It looks gigantic compared to its summertime position when it's almost directly overhead, and it starts to look really small. And that visual compression is a maddening artifact of our human eyes and the way that our brain scales that visual information. It's kind of interesting. And that's the same reason the moon looks big when it's on the horizon as compared to when it's above in the sky, away from the horizon. I mean, there's a little bit, ever so slightly amount of, atmospheric refraction is causing some of that effect, but it's mostly the visual compression that your brain plays tricks. I mean, really, it's crazy. So I think that might be where we leave our program tonight. If anybody has any questions, we'll hang out for a few minutes and see if those questions pop up in channel. And if not, we'll probably give it till about 8:35 for questions, and then we'll call it a wrap. So I'm really excited for this spring season. Galaxy season is one of my favorites. It's pretty dry galaxy-wise during the fall. We've got two galaxies, really, M31, which is Andromeda, and M33, which is Triangulum. And both of those are very close together in the sky. And I'm actually working on an Andromeda project that, while we're waiting for questions, I will kind of give you guys a visual on, if I know which one to pull up. It's a giant mosaic. Where is it? This one. This one. let's see. I need this program. So Andromeda is quite a bit larger than what we were looking at tonight from a scale perspective. My telescope, the same telescope that I was using tonight to show you those galaxies, we were looking at things that are the size of this galaxy down here in the lower corner. That's a satellite galaxy of Andromeda. That orbits Andromeda, and that takes up one frame of this mosaic. And this is 13 images that have been tiled together, and I haven't completed the data on the right side that you can see there. It kind of gets cut off, but once I get that data, I'll have the whole Andromeda galaxy across at a pretty high resolution because I'm using the mosaic method. So like if I zoom in on this, you can really start to see the structure in the gas clouds and dust lanes of Andromeda going into the core that really show you its grand. This is considered a grand spiral galaxy, and it's a little bit larger than the Milky Way, but not terribly larger. And it's one of the few galaxies that are moving towards us. In a few billion years, Milky Way, which is our galaxy, and the Andromeda galaxy are going to have, it's termed a collision. It's better to call it an interaction because galaxies are a lot of open space. So to consider them colliding, it's more like if you poured two streams of sand together, to put a different analogy on it. So yeah. But yeah, I appreciate everybody coming tonight. I think with that, we'll close up in about a minute. And I hope everybody, had some fun. I know that the live YouTube experience is not quite the same as coming out to the observatory. But on a clear night like tonight, we are able to do some telescope work and show you guys what's in the sky tonight, as opposed to what's in the sky, 3 months from now, or 3 months ago, or 6 months ago, using pictures. It is, as we showed tonight, the galaxies are pretty hard to see when you're trying to do it as a single exposure in a timely manner for this type of experience. But just having those pictures on standby to like drag in and show what the visual of those galaxies is, it works pretty well. So hopefully we can continue to do this all year. I know we're going to try and make this a regular thing. Eventually, we're going to try and broadcast from Frosty Drew. I don't know what that's going to look like, but it's something we're trying to do and improve our outreach, and hopefully it goes well. So again, appreciate you guys all tuning in to this Frosty Drew live session here on YouTube. And with that, I think we're going to say good night.